we are making the connections for PCM circuit. In this first connection that you have to make is, first we are using there are two parts, one is the DC, one is the AC. First we'll do the DC. So we are connecting the DC to 5 volt input here. The next connection is the output of 5 volt goes to this input. The next connection which we have is the clock. The clock output goes to the clock conversion input. The serial clock goes to this and this serial shift clock block. The output of serial data goes to serial data input. Another serial clock output goes to here. The parallel clock from these 2 points, one goes to this parallel clock and other goes to this parallel clock. Now I'll explain the working here, what is happening right here. We are using the DC. The DC is sending the PWM. So I'll turn to slow. So this is my binary 1. So as you can see, this is going into binary mode. Like this is the input, this is my output. It can be realized easily by removing any of the connection. So this is the analog version of pulse code modulation, in which we are transferring analog basic DC voltage and we are converting it to a digital signal. So this is basically so like this is 8 2 4 8, this is 1 2 4 8 16. So this will be my digital, the digital conversion of the analog. Now similarly, if we change that input to this one, this section is for AC, for our sine wave. Now what we will be doing is, we will be connecting a DSO. Our DSO will show us what is the input. First we'll connect the ground, then we will connect the output. You can see here, this is a 55 Hz signal that is at output. Now we will go towards the input. This is our input, 55 Hz. This is in a slow mode. Now the difference between slow and fast mode is, it's the sampling rate. You can see here clearly on the DSO that the sampling is very clear. As soon as turn this from fast to slow, there will be samples. And this is my serial data. It can be seen here at this point. You can check the serial data. You can also check the serial data if you connect the DSO at this point. This is a PCM encoded data. This is a PCM encoded data. You can see that the data will vary. This is at minimum. The PCM is seen at this section at serial data output. The input can be checked here. 183 Hz I can increase and decrease the amplitude and the frequency from this point, and I can change the frequency from high to low. This is 1.88 Hz, and this here we can get the output in fast mode. So to get the output, you have to check the input at this point and the output at this point. To check the modulation, you can check at this point. Rest are clocks for the processing of the PCM.